Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you UDP, User Datagram Protocol. And here I'll explain you why should we use UDP in computer network. There are so many reasons. Before we see frame structure of UDP, you should know first why UDP is preferred in computer network. See, UDP is connectionless protocol unlike TCP. We have already seen TCP in great detail, right? In TCP, we have three stages: connection establishment, data transfer, and connection termination. So for connection establishment, you need to have some time. Then you will be forwarding data. That data forwarding will be reliable data forwarding. And in connection termination, we will be terminating connection in between source and destination, right? But in UDP, we don't need to establish connection. That's why you will be saving some time. So here, see, UDP is used for real-time applications. So in real-time applications, you don't have time for connection establishment, data transfer, and connection termination, right? So that's why in real-time applications, we use UDP. In real-time applications, we prefer more speed over reliability. As if you want to have reliable data transfer, like as if you want to forward video file, then you should prefer TCP, in which you will be forwarding data with reliable service, where there will be no data loss. But as if you talk about real-time applications, like video chat, so in that situation, you will be using UDP, in which speed is more concerned. We are not concerned about reliability. If some data are missing, then also that is fine in UDP, right? As if you have real-time application. So you should know, see, as if you want to forward file, at that time you should be using TCP. But for real-time application like live streaming, video chat, you will be using UDP. Why? The reason is, in video chat, if some data are missing, then also it is fine. But application should be real-time. If you have connection-oriented service like TCP, in that situation, what will happen? There will be more time for buffering. It will consume more time, and because of buffering and delay, TCP is not preferred in real-time applications, right? So UDP is used for real-time applications where speed is more concerned over reliability. See, in multicasting and broadcasting also, UDP is preferred. Now you might be thinking, like, why should we have UDP over TCP for multicasting and broadcasting? So let me explain you that by one practical analogy. Here you see we are having one sender. In multicasting and broadcasting, we will be having multiple receivers. So let us say receiver R1, R2, R3, R4. That is how multiple receivers are connected over here, right? For broadcasting and multicasting. Now see, what will happen is, in case of TCP, there will be sender window and receiver window. So receiver is having window over here. So with receiver it is fine. There will be single window. But with TCP, sender will be having separate window for all the receiver. So here I am showing you 4 different windows for 4 receivers. But if you talk about practical scenario, like in broadcasting, let us assume you want to broadcast message to 100 receivers. So with 100 receivers, you need to have 100 windows over here, 100 sliding windows with TCP. So at that time, the sender requires humongous computational complexity. Like CPU should be very powerful at sender, as if sender is broadcasting message to 100 people. Why? The reason is, you need to have 100 sliding windows. So that's why, see, TCP is not preferred for multicasting and broadcasting. Here we should prefer UDP, where we will be having unreliable service, right? See, for unreliable broadcasting and multicasting, only UDP should prefer. If you wanted to have reliable multicasting and broadcasting, then you should go for TCP. But in that, this sender will be having higher complexity in terms of CPU. There will be more memory in terms of RAM for data access, right? So that is highly required in case of broadcasting and multicasting, right? See, if protocol needs few request and response packets, then also UDP is preferred. Like you see in TCP, for connection establishment, there will be three-way handshake. There will be three-way handshake. So those three-way handshake will make sure there is connection establishment. Then after there will be data transfer, right? But if the protocol that needs few request and response packet, like we have already seen how BootP is there, how DHCP protocol is there, how routing protocol like OSPF is there. So in that we just need to have few packets only, right? You don't need to establish connection like three-way handshake every time. So in that situation, we don't prefer TCP. Now you might be thinking like how you can say this protocols uses UDP. I'm not saying these protocols are using UDP. What I'm saying is inherently it is accessing computer network as per UDP. Inherently these protocols are accessing computer network as per UDP. See, in UDP we don't provide connection establishment, and in TCP we need to have connection establishment. So for BootP, for DHCP, do you think like you are providing connection establishment and then after you are accessing internet? No. Practically when you turn on your computer on computer network and when you see how many packets that we are receiving, so in that when you talk about TCP data transfer, so before data transfer we were been having connection establishment. But in case of BootP, you just need to have few request and response packet. You don't need to have 3 packets for connection establishment, right? If you have, in that case, your services will be very slow. So inherently, you can say these protocols are using services as per UDP, right? So in short, all you can understand is, see, TCP, that is reliable service in which there will be no data loss. If some data is missing, in that case there will be retransmission. In case of UDP, we are having connectionless protocol. You don't provide connection establishment and all those stuff. Here you will be more concerned towards speed. So as if you need to have more speed, then you should go for UDP. In real-time applications, we need to have UDP. Why? The reason is speed is more concerned. Like as if you talk about live stream, video chat, in that we need to have higher speed, right? Here you don't need to have higher reliability. If you wanted to have reliability, in that case you should go for TCP. Like if you wanted to have file transfer, then you should go for TCP, right? But for real-time application, we should go for UDP. As well as one more essential thing that you should know, for multicasting and broadcasting, UDP is preferred if your services are unreliable. Unreliable means if some data are missing, then also it is fine. If this kind of services are there, then UDP is preferred. So first of all, you should know like why UDP that should be there on computer network and why TCP should be there on the computer network, right? And based on comparison also, I have made one video earlier with first chapter of this computer network lecture series. But still, I'm making this video to make sure when you see UDP frame structure at that time also, your mind should be clear like why UDP frame structure is like this, right? So this is how basics are there with UDP. Still, if anything that you like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.